Hi there, third graders. We're going to move on with area and perimeter. You guys know a lot about area and perimeter. Well, now we're just going to kind of play around with it and manipulate it and just kind of see what we can do, changing and kind of moving around the area and the perimeter, just dealing with rectangles though, okay? So we know the formula for the area of a rectangle is the length times the width. And in order to find the perimeter of a rectangle, we just add up the sides, right? So let's say we have I'm just going to make one up here. Let's say we have a rectangle that is 3 centimeters by 4 centimeters. We know that the area equals 3 times 4, so the area is 12 square centimeters. Right? And it would kind of look like this if we could see the square centimeters. The perimeter, we need to figure out, oh, we've got 4 on this side and we have 3 on this side. So 4 plus 4 is 8 and 3 plus 3 is 6. And the perimeter then is going to be 8 plus 6, which is 14, not squares, but 14 centimeters. Okay? So what if we wanted to create another rectangle, brand new rectangle, and we want to make sure, but we want to arrange the square centimeters differently. We want to have the same area, but a different perimeter, which means we're going to take these squares and create a different rectangle, but use them all, okay? So you have to think to yourself, well, how can I use 12? How can I make an array with 12? And not have it be 3 times 4. What's another multiplication fact that equals 12? You could do 2 times 6, right? So that would mean your rectangle would be 2 times 6, right? And if you have 2 times 6, we have the same area. We still have 12 square centimeters. We have 6 plus 6, right? But our perimeter, so our area is the same. Our perimeter is different because we have 6 plus 6, which is 12, 13, 14, 15, 16 centimeters for our perimeter. So if we were to have a yard this shape, we would need less fence line, right, than if we had a yard this shape. Kind of long and skinny, okay? So you can do the same thing doing it the other way, where you have the same perimeter and you want to create a different area. So let's try it with the same deal. Let's say this is our, we'll keep it as centimeters. Let's say this is our rectangle. If we want to know, if our goal is to create another shape that has the same perimeter as this, but a different area, we first have to know the perimeter of this. So this is 3 and this is 4, so our perimeter is 14 centimeters. Okay, because it's 8 plus 6. We're not calculating the inside, all right? And let's say we want to use this 14 centimeters. We want to create we want to use 14 centimeters again. We only have, let's say we're going to make a fence and we want it to be 14 centimeters long. Shouldn't make any sense for a fence, for centimeters only this big. But the inside is going to be a different size, all right? So, which means the area is going to be different. Perimeter is going to stay the same, area is going to be different this time. So our perimeter has to be 14, so we have to figure out how can we make a rectangle with 14, and the best way to do it is to just kind of play around with it. So I'm going to say, I see a 10 and a 4. So I'm going to do the 10 like this. I know my sides have to be the same. And then I'm going to do my 4 like this. So I have 10, 11, 12, 13, 14. So I have used 14 centimeters as my perimeter. But now when I look at my area, I'm going to have a different area. Right? I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square centimeters, because 5 times 2 is 10, and this one has 12 square centimeters, right? So this would be This would be a bigger yard using the same amount of fence line. This would be a longer, skinnier yard. It kind of is shaped funny. Here, it would look more like that, right? There we go. Look more like that. Okay, this one, using the same amount of fence line, you get more of a space. Okay? Now, you are going to be going back and forth like that with in your book. You're going to have to draw and create shapes that have the same area but a different perimeter, or the same perimeter and a different area. All right? And one way to play around with it is with the graph paper you were given, or in your book, you have, in the very beginning of your chapter, you have these square units. And if you cut apart those squares, you can use those for your area, and you can figure out what rectangles you can make. Okay? That might help you when you have to keep the area the same and the perimeter a little different. Okay? You're not going to do all of the questions, but you're going to start with number 1, and you're going to do 2, 3, 4, 5, number 6. And on number 7, they give you the length and the width, and you have to figure out what that rectangle would look like. So for instance, it says window A is 6 feet long and 3 feet wide. So you draw on a piece of paper window A. Window A is 6 feet long and 3 feet wide. Okay? So it's like that. Window B, it says, is 5 feet long and 4 feet wide. So it'll be wider, shorter. It's going to be 4 by 5. Right? So this one has an area of 18, and this one has an area of 20 square feet. It says it's a big window. Square feet. All right? And you're going to be determining, there's another window you have to figure out the area for, and then you have to determine which one is using the most square feet. Okay? You're also going to have to use those windows. When they talk about windows, they're talking about these windows you created on paper for number 8, and you're just going to do all the way to number 9. Okay? Don't need to do 10 and 11, although they're challenging, and if you want to challenge yourself, you can try them out. Okay? So, have fun. Let me know if you have any problems. See ya.